Our eyes are a miracle of the nature, but we are technically unable to recreate the eyes to the same standard. And because our cameras and especially our monitors are not as good as our eyes, we have to invest in special camera settings and a lot of work in post-production. And this 15-part course is designed to show you how to get better shots. Why? Look at this underpass. Our eyes can detect about 20 f-stops, that is, differences between light and dark, and so we can easily see everything in the dark in a tunnel and also in the bright sunlight. One aperture stop, also called an f-stop, doubles or halves the amount of light. The image looks completely different on our monitor. In front of the sun and behind in the tunnel, the center line is not even visible. Information in the image is lost. Monitors can only display about 6 f-stops, HDR maybe 8. The camera, however, can display around 13 to 14. Very good cameras can display 15 f-stops. So we can edit this image and adjust the bright area and darken it, and brighten the dark area. Suddenly you can see the center line in the sun and in the tunnel. So our camera can do a lot more than the monitor, and this workshop will show how we have to work with the limitations of the camera, but also how we can map the higher performance of the camera to the lower performance of the monitor. In this first part, we'll learn how to use the waveform,
how to easily understand what the individual effects do, and that the camera can do much more than our monitors and projectors. I've been filming for over 30 years, and in addition to feature films, experimental films and nature films, I also make many reports and documentaries, where there is often little time to set up the camera correctly. Is part 1 of a 15-part course to increase knowledge and skills that I have acquired during this time. The courses are absolutely suitable for beginners, but will also include good tips for advanced users, and even professionals will probably find something, especially with ISO and film log. I've been a member of Landshut Film Club since 1992, and thus also of our non-profit Bavarian Regional Association and our federal association, the BDFR, which has existed for 98 years and in which 54 film clubs are organized nationwide. We organize festivals nationwide, free of charge for members, where the films are discussed in detail by expert juries, and exceptional prizes can be won. We have our own film and video magazine, and regularly hold workshops, including this one. Become part of the strong community, links in the information. I use Grass Valley Edu's myself and for this course. The software is well suited for large projects and has very good output quality. In order to make the right settings for a good image, we need tools to help us. I'm using the editing software Grass Valley Edu's here, but all the functions shown should also be available in your editing program, possibly under a different name. If not, you should indeed change. A very powerful tool is the Waveform monitor. It shows us the brightness distribution of the image, and if you are a bit practiced, you will immediately see where the problem lies. The brightness values of the vertical columns are plotted vertically for each point, from white at the top to black at the bottom. Here you can see the bright sky as a cloud of points, with the dark walls to the left and right. This is only about brightness. Even so, you can definitely see color. For a better explanation, I will walk through the image wearing a white t-shirt, and due to the brightness of the t-shirt, you can see in the waveform that there are more bright spots there and they move with me in the waveform monitor. If you crop the image from right to left, you will also crop the waveform. It displays the columns. If you crop it from above and below, the width remains in the waveform. With the mask, you can even cut out and evaluate individual areas. It is important to understand this tool correctly, because it allows us to access the brightness and the contrast of an image, regardless of the monitor settings. We will also use this tool repeatedly in the following sections. To enhance your image, we need to understand what the individual effects do. To do this, I create a color matte with two colors, black and white, that changes from left to right. As expected, we get a gradient from black on the left to white on the right. With this, we can now easily find out what the effects do. The waveform monitor shows a single line from left 0 to the right 100. Why a line? Well, in the vertical column, all the points are equally bright. From the very left column black, through the middle gray, to the very right white. Now we apply the brightness effect and see that when we brighten the image, then this line moves upwards. The slope, so the difference between the individual points, the contrast, remains the same. The same thing happens when we darken the image. The line moves downwards and the slope remains, except when we notch the top or bottom. Brightness therefore changes the brightness for each point by exactly the same amount. Next we use the contrast effect. If we increase the contrast, then the line becomes deeper. That is, the brightness difference between two different points becomes larger. If you reduce the contrast, the line becomes flatter until it is horizontal at the end, and all differences disappear. So as expected, brightness changes how bright each individual point is. Contrast, on the other hand, enhances differences or reduces them. Now we can also look at other effects, called primary color correction in EDIOS. Lighting works essentially like brightness. Exposure, on the other hand, keeps black black and makes all other points brighter. This prevents the image from bleaching as much. Darker is also possible, of course. Gamma, sometimes called shadow, increases the dark points more than the light ones. But black remains black and white remains white. The image becomes brighter without being overexposed. I use this effect very often. Here's a practical example. The entrance to that store in the sun is very bright and has influenced the camera settings, and inside the store it is therefore very dark. It would take a lot of lamps to compensate for that or to create this effect. Amplification, sometimes called highlights, decreases or increases the brightness, but black remains black. We will see later what this particular good for. Then there are the gradation curves. Here you can influence the brightness even more precisely using a line. EDIOS has an RGB curve that reacts significantly more tamely than the YUV curve. This black and white gradient in conjunction with the waveform monitor is also a good tool for seeing what effects are doing, in case you forgot. Now for this frame we have values above 100 in the waveform. How can that be? Let's go back to creating the color matte. If we click on white there, we see 235, 235, 235 3 times for red, green and blue. But it goes up to 255. If we enter 255, an ERE warning appears in EDIOS. ERE is the abbreviation of the former Organization Institute of Radio Engineers. It ensures that the voltage of the analog video signal remained between 0 and 100. Over 100 is super wide. Earlier analog monitors could then lose synchronization. That's why TV stations today don't accept videos with an ERA waveform above 100. The same applies to black. Here we see the value 16. If we go below that, the warning also appears. That's super black. But let's create it anyway. We see that the line in the waveform goes above and below. Now you know how to correct that, right? Right, by reducing the contrast. But if we overlay them, then we see that the color map from 0 to 255 in both black and white has a much larger range, which actually no longer shows any visible differences. This is one of the weak points of the monitors. We can also only correct values above 100. To do this we use the gain or highlights effect. And we see that we suddenly have significantly more structure in the clouds in the image. We suddenly see differences. Another example. The woman in the picture is wearing a lot of black clothes, but also white. At first everything black looks more like a black hole. We need to edit this now. With gamma correction we can make the dark spots brighter and with thus bring them into a realm where we suddenly see the differences. We see all the little wrinkles and where the pans end and stop begins. The camera recorded all of this, but the monitor couldn't display it. Another example is this ship on a sphere in front of Hamburg City Hall. Against the sky you can see only a dark silhouette. If you now brighten the ship using gamma shadow, you can suddenly see that the ship has golden elements. We make things visible on the monitor that the camera has captured. Remember, it can do more than our monitor, but the monitor can't display without processing. In a final example we have both overly bright areas, the sky and left row of houses, and simultaneously two dark areas, the golden man under the arm or my jeans. If we balance both, we also see that there is now more color in these areas, even though we haven't changed the color at all. On the left, the houses are more colorful due to the darkening, or rather we can only see the color at all. On the right under the arm, the gold is suddenly more visible to the lightning. A well-exposed image always appears more colorful. We'll learn later why. We have now learned the basics and can learn in the next 14 courses how to take good pictures with the camera and then change everything in our editing programs so that we get the best possible image for monitors and projectors, or even make the seemingly invisible visible again. It's not just about aesthetics, it's also about audience guidance, as we will learn. And most of our display devices are more or less incorrectly adjusted. Only the projectors in the cinema are calibrated. But the better our image is, the better it will appear even on mediocre display devices. Here are the further topics. Please feel free to ask questions about the individual parts in the comments. I'll be happy to answer them or include them in later parts. If you enjoyed this, please leave a like and above all subscribe to the channel and set the bell to all so you don't miss any of the next courses.